Our next step is to generate our solution to this problem. So what type of problem are we dealing with? Well, we know that the temperature in this eye is changing. We're told that it's initially at 37 degrees Celsius, and we're told that over time it needs to change to a temperature of 60 degrees Celsius at a depth of 250 micrometers into the surface. So because we have this temperature change over a finite amount of time, we know that we're dealing with a transient problem. So we know we can use our unsteady state flowchart as a guide for solving this problem. Now we use our unsteady state flowchart to determine how many ways we have of solving this problem. Our first step is to usually calculate this alpha t over L squared value. However, we're not given an L. And because we're not given an L, we know that we can't use a lumped parameter analysis, and we can't use a Heisler chart, so we're pretty much just left with the semi-infinite geometry solution. So that's one way of determining that you need a semi-infinite geometry solution for this problem. Another way of determining that we can use the semi-infinite geometry is from our assumptions. So in our assumptions, we assumed that our eye thickness is quite thick. And we're also told that we're worried about the temperature after 250 milliseconds. So because our geometry is quite thick, and because we're dealing with such a small time scale, we can assume that inside of the eye, far away from the surface, our temperature is remaining constant. And these are two conditions necessary for the semi-infinite geometry assumption. So we've already determined we're dealing with a plane structure, or plane surface. So we can go ahead and use our Cartesian coordinate system to define our x-axis, beginning at the surface, where the surface of the eye is x equals 0. Now we have to determine our boundary condition. And this is a very important step because depending on which boundary condition we're given, either 1, 2, or 3, depending on the boundary condition, we're going to be using a different solution to our semi-infinite assumption. So what I mean by that is that if we're given the surface temperature, we're going to be using one equation. If we're given the flux, we're going to be using another equation, etc. So for this problem, we're told that we're using some flux of laser to hit the surface of the eye. So clearly we're dealing with the second type of boundary condition in which flux is given at the surface. So now we can refer to the textbook or our equation sheet to find the correct semi-infinite solution with the surface flux given. And in this case it happens to be this equation right here, which will allow us to solve the rest of the problem.